And hello teacher, my student number is CST2409010, and today I would like to talk about the application of derivatives and what's your method to find the volume of a solid revolution and moments and the center of mass. So first I would like to talk about the definition of derivatives, and this is the formula. And the derivative of a function reflects the instantaneous rate of change of the value of the function with the change of the independent variable, or the tendency and speed of the change of the function near a certain point. The derivative describes the tangent slope of the function graph at a certain point. So you can see the formula. Fa derivative equals fa plus h minus fa over h when limit h approaches to 0. So first I would like to talk about the cost function. The cost function reflects the total cost of producing units of a product, covering various most cost elements. Its derivative, known as marginal cost, shows the change in the total cost when an additional unit of product is produced. So let me give you an example. So fx equals 0.1 x squared plus 10x plus 10, and this is the cost function, and the marginal cost is 0.2x plus 10 is derivative. When x equals 200, the derivative is 50, which means that the cost of producing one more unit of the product will approximately increase by 50. This helps enterprises make decisions regarding the scale of production. And the average cost functions is cost functions over the numbers of units. The average cost function shows the average cost per unit of product. Its derivative is used to find the minimum value of the average cost, guiding enterprises to optimize cost. So for example, fx is this one, and gx is fx over x, which is 0.1x times plus 10 over x, and its derivative hx equals 0.1 minus 10 over x squared. So we setting hx equals 0, we get x equals 10, at which point the average cost is minimized. And the revenue functions. The revenue function describes the total revenue from selling units of product and is often related to demand. Its derivative, namely the marginal revenue, reflects the change in the total revenue when one more unit of product is sold. So for example, the revenue function Rx equals 100x minus 2x squared, so its derivative equals 100 minus 4x. So maximum revenue is achieved when 25 units are sold, which means its derivative equals 0. And the average revenue function is the same. The average revenue function represents the average revenue per unit of the product. Its derivative assists in analyzing the change rate of average revenue, helping enterprises understand the profitability of the product. So we let the average revenue function equals 10x minus 0.1x squared. So the average revenue function is 10 minus 0.1x, so its derivative of gx is negative 0.1, indicating that the average revenue decreases as the sales volume increases. The next is the profit functions. The profit function represents the total revenue minus total cost. Its derivative, known as the marginal profit, reveals the change in profit when the quantity of production and sales changes. So for example, the total revenue Rx minus 8x squared minus 2x, and the total cost Cx equals 3x squared plus 5x plus 10. So the profit function pi x equals 5x squared minus 7x minus 10. So, and its derivative is 10x minus 7. So we know that when x equals 0.7, we have the minimum profit, which guides enterprises in making profit-making decisions. And the average profit functions is the same. The average profit function, its derivative, helps to understand the behavior of the average profit and assist enterprises in planning their operations. The average profit functions is profit functions over the unit of the products. So as you can see in the screen, the PAX, which is profit functions, equals 5x squared minus 7 squared minus 7x minus 10. So the average profit functions equals 5x minus 7 minus 10 over x. So its derivative of Rx is 5 plus 10 over x squared, which means it's positive when x greater than or equals to 0, indicating that the average profit increases as x increases. So next, I would like to talk about the Washer method to find the volume of a solid of revolution. The Washer method is a technique used in calculus to find the volume of a solid of a revolution. When a planar region is rotated about an axis, the volume of the resulting solid of revolution can be calculated using integration. It is mainly applicable when the planar region is bounded by two curves and forms a shape similar to a washer, a disk with a hole in the middle, after being rotated about an axis. And this is the formula. So where this formula comes from, so let's see. So as you can see in the first picture, there are two curves, and the area in the middle looks very like a washer. And the rotating body can be cut into the infinity numbers of disks, as you can see in the right picture, and its volume can be viewed as the sum of the volumes of these infinity numbers of disks, and the volumes of each disk. You can see this is the formula: pi r squared h minus pi r squared h, and h is the thickness of the disk. So we can integration the first formula, and we can get the second formula. So if the curve rotating about y-axis and the function turns to the third one, it's dy, not dx. And this is an example. Find the volume of solid generated by revolving the region bounded by parabola y equals x squared and y squared equals 8x about x-axis. So first, we can see the intersection of the two curves is 2, 4. So we can use the formula to solve these problems. V equals pi integration from 0 to 2 r1 squared minus r2 squared and dx. So in this situation, r1 is y1 and r2 is y2. So next step, we should substitute y with x. So as you can see here, this one equals pi integration from 0 to 1 8x minus 8 squared dx, and finally we can get the answer. And then it's moments and center of mass. So first is moments. In physics and mathematics, the moment of a point mass about an axis is a measure of its tendency to cause a rotation about that axis. Mathematically, if we have a point mass m located at a distance r from the axis, the moment about the axis is given by m equals m times r. So this is an example. Consider seesaw. If a child of mass m equals 35 kg is sitting at a distance r, 1.5 meters from a fulcrum, the axis of the rotation, the moment of the child about the fulcrum is m equals m times r equals 52.5 kilograms times meters. This moment determines the rotational effect of a child's weight on the seesaw. And the center of mass of a system is a point where the entire mass of the system can be considered to be concentrated for the purpose of analyzing its translation motion. So for a system of particles in one-dimensional cases and usually lying along x-axis, if we have point masses m1, m2, mn located at points x1, x2, xn, the coordinate of the center of mass is given by this one, and x bar equals sigma mi times xi from 1 to n, and over mi sigma from 1 to n. And as you can see in the picture, the point O is the center of mass of this triangular. And the center of masses x bar, y bar of a system of n masses m1, m2, mn located at points x1, y1, x2, y2, and xyn in the xy plane is the same. So you have to pay attention that the x bar equals to my over m, and y bar equals mx over m, and the m here is the total moments. So this is an example. So find the moments and the center of masses of a system of objects that have masses 3, 4, and 8 at points -1, 1, 2, -1, and 3, 1 respectively. So first we know that m1 equals 3, m2 equals 4, and m3 equals 8. So we can find m equals m1 plus m2 plus m3 equals 15. And mx equals m1y1 plus m2y2 plus m3y3 equals 15. So we know that x bar equals 29 over 15, and my equals mx1 plus m2 x2 plus m3 x3 equals 29. So from this information, we know that x bar equals 29 over 15 and y bar equals 1. And as you can see in the right graph, it's these 3 points, and this one is the center of mass. It's the same as we solved. So the conclusion: derivatives had several applications in economics. They can be used to analyze costs, revenues, and profits. For example, marginal cost, the derivative of cost function, help to enterprises determine the scale of production. Marginal revenue is used to guide sales strategies, and marginal profit can direct enterprises to maximize profits. And the Washer method is a way in calculus to calculate the volume of solid of revolution by integration. And moments are used to measure the effect of source on making an object rotate, and the center of mass is the equivalent point where the mass of system can be considered to be concentrated. And both of them play crucial roles in analyzing mechanical problems such as object rotating and mass distribution. Okay, thanks for watching.